Okay, let's start the question which is solved yesterday with you. The first question is, add the numbers that came from port 2 and port 3, and we did a solution about this question as like that. I will copy it to the Keil. Sorry, we don't need to write again this part. Yes, we can solve by using these commands. In here only we want to sure about this command. Actually we check it on the command table, but let's try it is true or not. When we build this program, when we compile this program, we can see no error and no warning. We can go to the debug session part, and here we need to port 2 and port 3. Port 2 and port 3, so we can get from this part port 3 also. We will do an addition operation, so we can specify the value by using this box. For example, 07 and 0f. What is the calculation? Let's try it before. Yes, hexadecimal number system, 7 plus f, and the result will be 16 hexadecimal. Okay, let's try it. Accumulator is 07 because we get the port 2 value, we read it, and when you execute this command line, the result will be loaded to the A, which is 16, as you see. That's all. This is the first question. Okay, what about the other question? If the result is higher than 158 decimal for the Q1, question 1, the LED connected to the port 1.6 will be turned on. Otherwise, it will be turned off. Okay, this is the second question, and we did solution as like that. Let's copy it again. Quit the debug session part and build before. Yes, we have no error and no warning. Before starting executing the program line, let's check it before. We will use port 1.6. So first of all we have to clear it, because the default value of the pin is logic 1, as you know. And then we read the port 2 value. We add the port 3 value to the port 2, and we will do a subtraction operation. Why? Because we want to compare this number with the result. So if we subtract this number from the result, and we can check the care flag. According to the value of care flag, we can decide it is greater or less than this number 158. How? If A is greater than this number, what will be happen? We don't have any care flag, so we can use the jump if not carry command. If care flag is 0, we will go to the greater label, and here we will do a turn on about the related LED. But if carry is 1, program this condition will not be satisfied and program will continue with the next line. Here we need to write clear port 1.6, which means turn off all the related LED. In here we need also as champ XX, Y. If we didn't write this command line, program will continue with the grader label. We don't want this command if carry is 1. Okay, let's try it if you don't have any question. Okay, first of all, let's learn this number in the hexadecimal number system. This number means 9E. Okay, 9E. So 9, sorry, E means this. Port 2, assume that port 2 is 9E. Okay, port 3 is 1. So the result will be greater than this number. Okay, we can easily check the program codes as like that. Let's try it. We need also port 1. So first of all we get port 1. Okay, in this program we need only port 1.6, so we cannot write move port 1 00 hex because we don't know, maybe the other pins of the port 1 will also used for the other purpose. We don't know. So if we use only one pin, we will do clear port 1.6 as like that. Okay, I will execute step by step. Port 1.6 is cleared. We read the port 2 value in A, as you see, 9E. If we add 1 to the 9E, it will be 9F. What about the carry flag? As you see here, carry is 0. But if we do a subtraction operation, we have to write clear command. Yes. After the subtraction command, carry is 0. Carry is 0. Why? Result is 9F, which is greater than this number. So this condition is satisfied. Program will branch to the line 12. Okay, grader label. Yes, as you see here, we are in line 12, and in here port 1.6 will be turned on, which is assumed. In here we have a LED. If we do this operation respectively, we can easily tends to the program to this line. Okay, line 4 for example. But in this question we don't need to write any successively operation. Yes, maybe we can check also if it is less than this number. How? Assume that this number is 1E plus 1. What will be happen? First of all, we have to reset this program. When we reset this program, the value of ports, as you see, FFX, and I will choose it is 0F and 0F. The addition of these two numbers is less than 158 decimal. Let's try it now. Yes, clear the port 1.6, read the port 2 value, add the port 3 value, which is 1E, 128, as you know, 9E, not 1E, so the result is less than 9E. Clear the C value, and as you see here, care flag is 1 now. Result is less than this number, so this condition is not satisfied anymore. Program will continue with the next line. Let's try it. Yes, we are in line 9. Clear the port 1.6 value and sjump XX. That's all. If this question will do 10 times, how can we do it? We need a counter in the program, such as move, I choose R5 for example, R5 10 decimal. After all of this operation, program will check the counter value and it will continue if it is not 0. Okay, how can we do it? sjump XX, sjump XX. Yes, program will already go in this program line. So in here we can write DJ and Z R5. If it is not 0, go to the which line, for example X1. What do you think about X1? Where X1 should be? What do you think? Which line? Okay, if R5 is 0, program will finish, so we need also an infinite loop. In this part we need also an infinite loop sjump X2. Okay, let's check it. We have no error, and let's do this question. Port 2 and port 3 value is not important for us. Maybe we can randomly select these values and continue. R5 is 10 decimal, which means 0A in the hexadecimal number system. This is the counter for us. Cleared, read the port value and add these numbers and check the numbers. It is greater or less than this number, and we will do this operation, and then we will go to the XX label. Yes, here we are in line 14. Decrease the R5 value, and if it is not 0, program will branch to the X1. As you see here, R5 is 09 now, and it will continue as like that. Now 08, 07, 06, 05, 04, 03, 02, 01, and 0. This condition is not satisfied anymore, and program will continue with the next line, which is an infinite loop. Okay, next question is do the required operation for question 1 and question 3. Maybe we should, yes, question 3. And if the button connected to the port 1.5 is pushed and released, we will do all of this operation. So we have already program answer. Let's take these program codes to the Keil. First of all, we can compile it. Yes, we have no error, no warning. Let's check the program. All program line is the same besides line 3 and line 4. In line 3 and line 4, first of all, we check the port 1.6 or 1.5. It should be 1.5, I think. Where is it? Yes, 1.5. 1.6, we have a let, right? Where is it? Yes, 1.6 we have a LED, 1.5 we have a button, so it should be 1.5. Yes. First of all, we check the button value. If it is 1, program will stay on line 3. If you press the button will be logic 0. So this condition is not satisfied anymore. Program will continue with the next line, and we check the button value. If it is 0, program will stay in this line. But if we release the button will be logic 1 again, and this condition is not satisfied, and program will continue in line 5. Okay, let's try it. Port 1.5. Yes, here this is logic 1 already. Yes, if you click step by step, program will stay on line 3 because we didn't press the button. When we press the button, program will go to the line 4 because this condition is not satisfied. And now we didn't release the button because, as you see here, the status of the port 1.5 is still 0. Okay, so program will stay on line 4. When we release the button will be logic 1 again, and program will continue with the same program commands. Yes, repeat the control process required for question 3 using subprogram structure. We need a subprogram and write the related assembly program codes to here. Let's get the program codes from here. Yes, first of all, quit the debug session part and compile this program. We have no error and no warning. Let's check the program, the same program line until this line, until line 8. Actually, we checked the control process here, but here now we need a subprogram, a call check, and we will do control process now in the subprogram structure, and let's try it. Clear, read the port, add the port, and subtract this number from the a call check. Yes, here we will check the care flag value with the same procedure, and this number is greater, so port 1.6 will be turn on and red. Please don't forget this. If you are in subprogram, you have to go back to the main program with the red command. Okay, it should be, if it is less than this number, result is less than this number, clear the port 1.6 and sjump xxx. Where is it? As you see here, line 16, which is red command. Okay, so it is so important for you. Okay, the next question is, division operation will be done instead of addition in question 1. This process will be repeated for 117 times with the numbers that will come from port 2 and port 3. The number of times that division by 0 has occurred in the operations will be determined, and the result will be saved to the 7th hex address. We need this. We have this kind of question, and we solve this question with you. Let's try to the program codes. Compile this program. We have no error, no warning, and okay, let's check the program line. First of all, we have a counter here. We used R6, for example. You can choose anyone, it is not important. And here 17 hex is address which is used for the number of the division by 0. Okay, if you don't know is there any information in this address or not, you have to clear before. We cleared 7th hex address before, and read the port value and port 3 value to the by division command will use only A and B. We'll do operation and equal check. In subprogram, we will check the overflow flag. Why? Overflow is set when the B value is 0. It means when we cross the division by 0, overflow flag will be 1. So if it is 1, we will go to the division by 0, and in here increment the 7th hex address. The number of the division by 0 will be increased. And red. When we turn back to the main program, here we have a counter, and counter check the desired number 117. If it is not satisfied, program will continue from line 5. Okay, that's all. In the subprogram, if overflow flag is not 1, program will continue with the line 13, sjump x1, and as you see here, we have return command again. Okay, let's try to the port 3 is 0, division by 0. Yes, R6 is 17, which means AA in the hexadecimal number system. 17 hex address. Yes, this is 00 hex as you see here, and get the port 3 value which is 0. When we divide A to B, overflow flag will be set. We can check the overflow flag from the program status word here. Yes, equal check. We go to the subprogram, and we check the condition overflow flag is 1 and increase the 70 hex address. As you see here, 70 hex address is 1 now. Okay, we can try another number. Go back to the main program and decrease the counter value, and it is not AA, now A9. As you see, we read the port 2 and port 3. Port 3 is not 0 anymore. Div AB overflow flag is updated, as you see. So we don't need to clear in this operation overflow flag before. Okay, all of the mul and div commands overflow flag for each operation will be updated. Yes, we are in subprogram. This condition is not satisfied. We will go to the red command because of schamp x1. Yes, as you see here, 70 hex address is not increased, and we go back to the main program. That's all.